Alrighty, here we are doing section 1.5, and this is just our intro with infinite limits. Infinite limits. Okay, so we may have a case where if we were to look at, say, something like, f of x equals 1 over x, and we look at the limit as x goes to 0 of 1 over x, and suppose we made a table, and so if that table, suppose we looked at coming in from the right, then here's x, here's 1 over x, and if I did 0.1, I would get 10, 0.01, I get 100, 0.001, I get 1,000, and so forth, right? If I go to 10 to the negative fourth, I'll get 10 to the fourth, or 10,000. And so we see, at least as I come in here, as I look at the limit as x goes to 0 from the right, I'm getting closer and closer to 0 with these positive values, 1 over x. Well, it appears to be undefined, because as I put in smaller and smaller values for x, closer and closer to 0, this thing just seems to grow without bound. Now, technically, here's our answer for the right-hand limit, undefined. However, we have in mathematics, just like in other languages, we have these euphemisms and other forms of types of speech where what we're doing, if we take it literally, it's actually not what's going on, but we still say it anyway. And I guess I like the idea of the phrase, you let the cat out of the bag. Okay, maybe you don't have a cat, maybe you don't have a bag, but you can still let the cat out of the bag, because you're giving something away. You gave away a secret of some kind, and so we have the same sort of thing in math, where this limit, as we move towards 0 from the right of 1 over x, it's undefined. Things grow without bound. Well, so if it's undefined, it can't equal anything. But in math, we still use that phrase to talk about this specific situation where something grows without bound, and we will say it equals infinity. And notice infinity is not a number. Okay, so nothing is equal to it. Okay, so it doesn't really happen. If somebody says, what's the limit? Mathematician may say infinity, but what you have to understand is what that, literally, that's not what it means. It means that, it grows without bound in the positive direction as we get near our target for the limit. So in this case, getting near 0. Now similarly, if I put in numbers, got close to 0 from the negative side. So if I put in minus 0.1, I would get negative 10. Minus 0.01, I would get negative 100. Minus 0.001, I get negative 1,000, and so forth. So we see the same pattern as happening here, and we see that the limit as x goes to 0 from the left-hand side, 1 over x. In this case, we would write is equal to negative infinity. It grows without bound in the negative direction, and so it's undefined, but we would say, you know, really what we're saying when we say equals either negative infinity or infinity like up here, then we're really saying it's undefined but in a very particular way. And that particular way is that it grows without bound either toward a positive number, you know, well, in the positive direction, not a positive number, but or in the negative direction. Now, in this case, then we see the limit as x goes to 0 of 1 over x simply does not exist. All right, we can write D and E for does not exist or is undefined or something like that. And here, we really can't say infinity or minus infinity because now, and here's the weird part again. We're going to say the limit as x goes to 0 from the left of 1 over x is not equal to the limit as x goes to 0 from the right of 1 over x. Well, of course they're not equal. They don't equal anything. However, had they both been positive infinity or negative infinity as our right-hand side here, then we would actually say the two limits were equal, even though, technically speaking, they cannot be, okay? Because they're not numbers, they don't exist, they're undefined. But so these are the kind of weird things about infinite limits. We use this funny language that everybody gets used to, but you don't want to get so used to it that you don't realize what the meaning really is. Okay, so you don't want to take it at its word that it actually is equal to infinity, because that can't happen. Okay. All right, and now we have a very formal definition of limits at infinity, but we're not going to use that at all in our course, and so I'm just gonna I think stop our introduction here with this and move on to other things then. So we'll stop.